There we go.
Okay, good. All right, I can see it. Okay, so I've been asked to speak to you all about electronics, and I'm going to give it my best shot. I'm going to speak about electronics primarily from the context of should you pick it as your concentration area? And I'll give an answer to that, but I'm going to cut to the end right here at the beginning and not have it be a secret. Fundamentally, what I want you to hear today is this is not one of those really important choices you make in life. There are lots of important choices you make in life, lots of them. I would argue choosing to major in electrical or computer engineering is a pretty important choice. Choosing your concentration area within electrical engineering, and by the way, I should say right away, there aren't any choices under computer engineering, but under electrical engineering, you get choices of concentration areas, but frankly, it is not that crucial. Let me explain that before I even talk about what electronics is. The key to understanding is that the concentration area does not appear on your transcript. That means that your potential employers will only know your concentration area if you choose to tell them. So let's suppose you picked electronics, but you later decided that you wanted to go into power. You don't have to tell those power employers that you're in electronics concentration. They just don't need to know that. They may not even know there are concentration areas, but certainly there's nothing we're going to tell them that tells them that. So you pick the concentration area that you think fits your career plans as you know them now, as best you can, and then don't worry about it. If you want to change it, it's really easy to change. And frankly, although it does guide some of your choices of electives in a sense, it doesn't really preclude you from going into any field of electrical engineering you want to go into. So this is not a crucial life choice. There are many crucial life choices. What should your major be? Who should I marry, or should I get married? Or lots of choices are important. This one's not a big one. Having said that, may as well make as good a choice as you can. Let me talk a little bit about electronics. What is electronics? Electronics is a kind of signal processing. I really like saying that sentence when there are other faculty who teach in signal processing in the room, because they always get angry when I say that. But it's basically true. Signal processing is what electronics is about. Now, let me dig into that a little bit more deeply. In the courses they call signal processing, you take a signal and you do a number of things with it. You might filter it based on frequency or other things you might do. In electronics, most of the things that we're doing involve amplification, but we only amplify signals. And that's really important to understand, and it's built into the whole framework of it. Let me say that all again in a slightly different way. You've all taken circuit analysis. You've all seen dependent sources. Dependent sources are amplifiers. And building a device that does what a dependent source does, that is, building a device that amplifies, is not obvious nor simple. And electronics is about how we do that and what kind of devices we use to do that and how they work and how to use them. So these things, you've heard of them, transistors. There's several different kinds of transistors. You'll learn about transistors of different kinds in different electronics courses because we use transistors to build amplifiers. Now we can do other things in electronics. We can do other things besides making signals bigger, besides performing the act of making a voltage that depends on a current over here, or a current depends on a voltage over there, or whatever. We can do other things beyond that, but most of them are built around this notion of what does it take to get a signal to be bigger? Not just bigger amplitude, more power. So, for example, audio systems. We often use them as examples. It's not the only thing we do, but it's a great example. I speak into a microphone. I'm doing that right now. The microphones happen to be in my ears in this case, but it doesn't matter wherever they are. They take sound and convert it to voltage or current, but it's so small that when it gets transmitted, it has to get bigger. And then the notion of transmitting it, what does that mean? What does it mean to send it to someplace else, either with wires or without wires? And then what does it mean to receive it on the other end and then make it into sound, which means you're going to amplify it as well and do other kinds of processing of that signal. That whole process, what I've got in these devices, what I've got in this device, that's what we call electronics. The devices inside them, the components, how they work together. What does it mean to amplify? How do we amplify? And what goes on the things needed for an amplifier? For example, things like how do you build a device that takes the wall plug voltage, which is sinusoidal, and make it constant? What we call a DC power supply. All these areas are what we would call electronics. What would I do with electronics if I were to go into electronics, Dr. Dave? You might go into instrumentation, and that's a pretty wide area. Instruments are used in everything, everything. There's no electronics in this pen yet, but I suspect there will be. I can tell you that in my lifetime, a huge number of things that nobody ever thought would have computers in them now have computers in them. Why? Putting a computer in them, we can make them work better. Computers are cheap and they keep getting cheaper. They're small and they keep getting smaller. They're effective and reliable, and they keep getting more effective and more reliable all the time, which means pretty soon I'm going to have some kind of device in this pen that tells me, hey, Dave, there's only 37% of the ink left. You're going to need to buy a new ink cartridge soon. And. We used to joke when I started out in engineering about the ideas of doing things like putting a computer in a dishwasher. And I can remember the day my father, who was an electrical engineer, brought home a dishwasher that they put a computer into. Why? Because they could make the dishwasher work better. And just try to buy a dishwasher today that doesn't have a computer in it. You can't buy one. Of course you couldn't. It would be a shame to buy one that didn't, because it wouldn't work as well. It would be more expensive. It would be bigger. It wouldn't clean as well. And. So what can you go into from electronics? Essentially almost anything. Okay, so we don't do an awful lot of software in electronics. It's not, computer programming is not a big part of electronics per se. On the other hand, I would argue almost every engineer programs at one point or another. So I'm not trying to downplay software or the importance thereof. I would just say electronics is wide, largely applicable, and likely to become more so with time. All right, that's my spiel. I'd be happy to take questions. That's what I'm supposed to do next, right, Colin? I'm supposed to say, I'd be happy to answer questions if you have any. Is that what I'm supposed to say?
I think that's what you're supposed to say, yeah.
Okay, I'd be happy to answer questions if anybody had them. And while you're thinking about that, I'm going to drink from my Dr. David's #1 cup here. Oh, it doesn't say that yet. Okay, anyways.
We are going to have to get the vinyl sticker. All right, so you have some questions in the chat. Would you like to look, or you want me to read them to you?
I think I can read them. It's good for you to offer read for me, but I think I'll keep trying. What kind of jobs would electronics include? You know, anything that an electrical engineer does could include electronics, I would argue. Now, let me just pick out some fields that I have personal experience with. I did research work in what's called well logging. Well logging, that game that oil companies play where they put things down a hole after they drill it to try and find out whether there's oil down there and how much. Well logging requires a significant amount of very sophisticated electronics that have to operate 2 miles down a hole that gets quite hot under high pressure. A lot of very difficult electronics go into that. And I've worked in medical ultrasonics. Almost all of medicine has electronics as a big part of what they're doing these days. And. So what kind of jobs? Many kinds of jobs. What's the overlap with the signals concentration? That's a good question, and I'm going to duck it. Good question, Kevin. Kevin gets a virtual candy for asking a good question that Dr. Dave doesn't know the answer. I don't know the answer because it's on the concentration plan, and you can look at the overlap between them as easily as I can. I encourage you to look at that. Look at that, pick a concentration area that covers the things you find most interesting. I suspect the overlap with signals will be significant, but I don't know how much there is. Would electronics be a good option to pick if I wanted to work with semiconductors? Yeah, I think it would, although you have other choices as well. What do they call it? The solid state option. I forget what the exact wording is. Both choices would be good for that. What's it called?
I believe solid state devices, right?
Yeah. So either one of those two. No, electronics doesn't heavily depend on coding, but almost everybody is called upon to do some kind of coding at some point. So I wouldn't pick electronics because you wouldn't have to ever write a computer program. That was probably not the way you should look at it. But I would suggest that electronics is probably has less emphasis on programming and coding than in some of the other options. Most versatile concentration. Oh my goodness. I'm going to have to duck that one as well. I don't know the answer to that. Versatile would mean that I would be able to tell you what's going to happen in electrical engineering in the future. And I'll tell you, I used to try to predict that kind of thing, and I was wrong so often, I stopped predicting. Okay, I will tell you just one quick anecdote. I can remember when one of my colleagues was telling me, this was in 1978, was telling me about how he wanted to have a computer in his house. And we laughed at him. Why in the world would you ever want a computer in your house, we asked. And he said, I'd want to keep recipes on it, which I do think is really a terrible use of computers. Probably the least best advantage of computers. Nonetheless, I was dead wrong about that. So I've stopped predicting. And to figure out what's most versatile, I'd have to know what's going to happen. And I don't know that. So I would encourage you not to think that way. I would encourage you to think this way. What do you find most interesting? What do you think is most exciting, or maybe even have a passion for? And whatever that is, go into it. Period. Knowing what's most versatile is probably not the way to think, because you're trying to predict what's going to happen and be flexible for what that's going to be. But I don't know what's going to happen, and you probably don't either. So pick the courses and the concentration that you think is most interesting, and then go with it. It's most likely to give you the right answer for you. You know, the questions about what an electronics engineer does on the job is a great question, but it's not one that I have contemporary answers for. If you asked me that question 40 years ago, I would have a good idea what the answer would be. Now, I am hoping that Colin and his buddies are going to have some industry people to speak to you. And that's a great question to ask them, and listen to what they say, and don't listen to what I say, because I'm really hopelessly out of date on that, and I don't know what the answer is going to be. Embedded has more overlap with signals. Yeah, I won't argue with that. Brian asked me to repeat his question. The question, I guess, was, would electronics be a good option to pick if I wanted to work with semiconductors? And I'd say yes, either that or the solid state option. Okay. I think I hit them all. Did I miss one? I don't see one.
I don't see one. Well, I have a question for you. How about that?
Okay, great.
How did you get to where you are today?
I'm sorry, say it again.
I said, how did you get to where you are today?
Okay. All right. So I decided when I was an undergraduate that I wanted to work on an artificial eye. And so I decided that to do that, I needed to go to graduate school. And I picked graduate schools that had good neurophysiology emphasis, faculty members working in the neurophysiology area, so that I could work on how the eye works and how the instrumentation would work and the equipment would work to build an artificial eye. And I therefore picked Duke University in North Carolina because there were two prominent faculty members there who were working in neurophysiology. I got to Duke and I found out that both of those faculty members were, I'm going to pick my words carefully here, turkeys. This stronger words would be more appropriate, but I shouldn't do this since you're recording this. They were inappropriate to work with. And I ended up shifting to a group, a research group that was doing ultrasound imaging. And in particular, they were building ultrasound imaging machines and building a computer into them. So that was basically a computer-controlled device, which at that time, which was again, the late 70s, 1970s, not 1870s, I should point out, the late 1970s, people didn't have computers in their equipment. And so we were building and figuring out how to build computer-controlled ultrasound imaging devices. And I worked on that for a number of years. I got my PhD. I decided, because I got a chance to do some teaching, that I wanted to go someplace where I could teach and do research. There's a long story about how I picked the University of Houston, but I got an excellent offer here, and I got to work both in ultrasound, medical ultrasound, and in this well logging field, which, you know, when in Houston, do what Houstonians do, when in Paris, do as the parasites do. So when I was in Houston, I did well logging. And so I've done research work in both areas, and I've had an opportunity to teach. Now it's close to 39 years now. So that's basically my life story in a little small capsule. Christina says, I want to work on artificial organs and prosthetics. Would you feel electronics concentration works for this? Yeah. Would I recommend a different concentration? No, I think this would be pretty good for that. You could do signals as well. There's a lot of signals work involved in prosthetics. So I think both of those things would be good. Should you take analog or digital electronics? I think you should take both. That's my opinion. I think they're both important and really useful. So, analog electronics or digital electronics? The answer, yes. Both and. What do you learn in those classes? You learn how to build amplifiers. You learn how transistors work. You learn how transistors work together, how we hook things together, systems together to solve technical problems using electronic devices.
Hey, Dr. Dave, I might have a request. If I pulled up
Sure.
concentration elective degree plan, could you kind of go over what some of the classes are?
I'll give it a shot. Is it the one that Milay put in the chat?
Yeah, I was just going to share it on the screen. If that's
Oh,
okay.
perfect. That would be great.
All right, let me get
Please
this
do.
pulled up then. Do. All right, cool. So I guess we can start at the top, and we'll just go, and I hope y'all can see my screen. Cool.
Okay, the electronics, the second from the left.
Yep.
Circuits and systems is a course that used to be called Circuits 2 before we broke circuits into Circuits 1 and Circuits 2. It builds on what we did in circuit analysis and a lot of things that are useful in terms of that. Things like how do you use transformers? How do you do Laplace transforms, which is also covered in other courses. Analog electronics is about that part of electronics where you're dealing with signals that are continuous in time, continuous in value, as opposed to digital electronics, which is when they're discrete in time and discrete in value. So here's the thing. More and more electronics works best if we keep things digital. But most inherent signals at the beginning and at the end are analog. So both are important. Not all signals, but most signals. Let's talk sound, for example, the example I used before. Sound is inherently an analog signal, but we store sound now mostly digitally. And there is electronics involved in both, and there's electronics involved in going between analog and digital and going between digital and analog, and we need to do both. Physical principles of solid-state devices involves how transistors work, also diodes, but transistors being the big thing. So 4339, 4119, physical principles of solid-state devices. That's a pretty archaic word. It covers the transition from vacuum tubes to transistors that happened about 50 years ago. When they made that transition,
I don't know about y'all, but I think he cut out on my side.
electronics course. Optics and photonics overlaps with electronics a great deal, so it makes a lot of sense to talk about that as well. Nano materials, again, how you build things in a particular small size. And so there's 3 courses, 5319, 5320, and 5321, all related to building small things. The nanosystems concentration seems to be rather rare, and UH is now taking out labs for it. You can certainly focus on nanotechnology in the electronics option. So you could think of electronics as giving you an option of blending nano topics, building tiny things in combination with electronics concepts. Again, I'm not going to predict the future of nanosystems. I hate predicting the future because I'm so bad at it. I don't know what the future of nanotechnology is going to be. What I do know is they've done some pretty amazing things thus far. I'm better at predicting the past than I am at predicting the future. Do you think that Intro to Robotics could be a good EC elective to take as an electronics concentration major? Sure. If you think robotics is interesting, it's a great choice. By the way, I could also say that if you were a nanosystems concentration and you thought robotics was interesting, or if you were in the applied electromagnetics option concentration and you thought robotics was interesting, I encourage you to say to yourself, what do I think is interesting? And if robotics is in that category, I would try to find a way to make sure I got to take courses in that. So they're listed here under signals, communications, and controls. Certainly controls is a big part of robotics. Electronics, I would argue, is as well, but it's not listed. Nonetheless, you have choices down here at the bottom, additional electives you can take, and you should take the electives that make sense for you in those additional electives. Did I answer your question? And I'd ask the same thing to Christina as well. I see from my screen that Colin is back. It's good to have you back, Colin.
Thanks.
Welcome.
Good to be back.
Good to have you back.
Apparently, and I had to switch to my phone. I was just thinking how crazy electronics are nowadays.
I'll tell you, a cell phone is a wonderful example of the amazing things you can do with electronics. Now, it's not just electronics. It's also programming. It's also embedded signals. It's also applied to electromagnetics. That cell phone wouldn't work well if it didn't have a good antenna that connected to the cell towers and other places, the Wi-Fi networks that it has to connect to. The idea of how effectively the batteries work is basically a power issue. So it is all of the above. So, I have a tendency to hold up my cell phone and say, if you think this is fascinating, you should go into electronics, but that's really misleading. really, if you think this is fascinating, you should be an electrical engineer.
That's the way to look at it right there.
And then pick a concentration area that you think is interesting.
That about sums it up, I think. Yeah, that sums up picking concentrations. What do you think is interesting? I think one thing to say, if y'all don't know, like you're trying to figure out what is interesting to me, I don't know. I have all these class names, which is why I thank Dr. Dave very much for kind of going through what some of the classes, entail, because I know from being on that side of things, it's like you look at a class and you get into it and it's like, it's not what I thought it was, but it's still interesting or not, depending on the class.
Yeah.
And if you're not sure about a class or two, just pick some random ones that look like they have interesting names or interesting backstories. And if you like it, you like it. If you don't, you don't. Make the A and pick another class.
And I will tell you some advice I got when I was a student that I always thought was good advice. When it was time to pick a course, I was told, find out who the good teacher is or good teachers are, and then take whatever they're teaching. Now, how do you decide who the good teachers are? You talk to other students. I've just been touting Stuart Long. I actually have attended his classes, but most of the faculty, I have not attended their classes. You shouldn't ask me about whether a given faculty member is a good teacher. You should be talking to other students about that. And when they say, oh, Professor X is a great teacher, you should be taking courses from Professor X, whatever he or she is teaching. That's my opinion. So that would be my answer to how to pick an elective if I don't know what I like yet. I would pick courses that my colleagues, my other students told me were taught by really good professors. I take those courses if I didn't have any opinion before that. Yeah, and frankly, it does vary from student to student. You shouldn't ask just one person. You should be talking to several people and listening carefully to what they say. If they say, "Oh, Professor Y is great because Professor Y always gives A's," I'm not sure that's the information you want. You want to know who's clear, who's interesting, who communicates ideas and concepts effectively. So don't just ask people who's good. Ask who's good and ask why. Professor Long happens to teach in electromagnetics. I think he teaches the antennas course as well. I think he teaches 5318 and 3318. That's my understanding. Yeah, I think Christina's right. You want someone who wants to be there in the room teaching, or in this case, online teaching, but someone who wants to teach is more likely to be a good teacher. And indeed, the ones who hate being in the classroom, who hate being on the Zoom session where you're taking the course, they're not going to be as effective. No, he teaches non-honors course students as well, but he does teach some honors courses. So he does both. But there's other good ones besides Dr. Long. Don't get me wrong. There are many good teachers in the department. Trick is finding out who they are. And again, the answer to that is talking to other students. I'm going to stop my share here. Colin, I don't know how long I'm supposed to speak. I thought I was told to talk for 15 minutes and it's now been 40. I think I must be over my time. Is that correct?
Yeah. I think you're good. Yeah, we only had 2 people signed up for this slot. We actually have a guy. I'm on the phone with him right now. His name's Tommy.
Okay.
Great guy. I'm trying to get him on right now. He had, I think he just got on. He was having some Zoom issues with his computer, but I think he just logged on.
Yeah.
So
okay.
Dr. Dave, I thank you very much for coming out. Feel free to stay, or if you need to go, we understand that too. So I guess everybody give Dr. Dave a round of applause. I certainly will.
Thank you. Thank you.
All right. Thank you very much. All right, students. So we have another guy coming on very soon. His name is Tommy Cooper. He's online. We're just trying to get his audio working and stuff. So if you guys will just hang tight for just a second and we'll get rocking and rolling.
Okay.
Can you hear me?
Yeah, I think I can hear myself too.
All right, we better, I'll turn off the phone.
All right.
All right, well, now we have our next guest coming on. His name is Tommy Cooper, and I think whenever he's ready, I'll just let him introduce himself. Just to recap, so Dr. Dave just came on and he was talking about electronics, the classes, just some good advice. And now we have Mr. Tommy Cooper. Tommy, would you like to tell us a little bit about yourself?
You bet. I'm going to close the door here.
Sounds good. It's been a while since I've seen that office.
Hello everybody, and let me give you a little bit of my background so you kind of get a feel for where, from where I'm speaking to you, so to speak. So I'm a U of H grad. I had a BSEE in 1974 and an MSEE I got at night in 81. So as I kind of started my career, I wanted to work on medical devices. So I went to work at Baylor College of Medicine, and I worked there for 5 years. I was in the surgery department, and as it goes, it always seems like I'm a name dropper, but I was working in the artificial heart program that for which Dr. DeBakey that was his artificial heart program. So we were designing controls for artificial hearts and other things. So we had both research responsibilities, and we had responsibilities for some clinical equipment. So I left there and went to work as a project engineer at several companies designing medical devices, defibrillators, and pressure transducers, disposable pressure transducers. In 1986, I started out on my own as a consultant. And so I've been, and I founded the company that I work for now, is Cooper Consulting Service. So we've been designing devices for all this time. I've been very fortunate and got to work on just a wide range of different devices. And as it goes, I'm way more into hardware and designing the electronics side of it than software. I used to do software. I wrote a lot of software when I was in the past, but I started hiring people who were better at it than me. So I gave them that, and they're still doing those types of things. They're taking care of all the software, whether it's firmware for an embedded or on such a wide range of things. We're working on a project for the Army, designing a automated pressure infuser for used in en route casualty care, like on helicopters, to infuse fluids into a patient very quickly. We're working on a robot system for treating PTSD. That's not a military product, that's a commercial product. We're working on fetal monitors and just we get to work on such a wide range of things. People ask me if we specialize in anything, and I go, kind of not, because we also, I'm working on a couple of laser-based products right now, where one of them is used for monitoring blood parameters, and it pulses a laser light, in one case through the skull and to the what's called the superior sagittal sinus up on the top of your head. In another place, it might do it right here in the suprasternal notch and looking for a vein down in there. We have another laser product that treats cancers like prostate cancer. So we're designing a system for a kind of company that I think the technology came out of rice because they use nanotubes. So I get to do all this hardware work. If you can't see it, but there's a breadboard right behind me that I'm working on. And I have a technician wiring up connectors and so forth. So yeah, I'm doing electronics every day. This what's sitting on my desk is schematics that I've been drafting the last few days. So we're designing that now. And I will tell you that I've always enjoyed hardware and doing that design work. I have to manage a lot of products, and I have to do a lot of writing because I'm in the medical device industry, but the hardware part of it is kind of my favorite part, doing those designs. So right now, I just ordered today a stepper motor controller. We've been working with more a TI IC, and now I've ordered another one from a different company and ordered their eval board. Working on thermocouples and interfacing thermocouples and thermistors into a medical device. So you can see it's all sensors and things that touch the body are more what I deal with, whether it's an electrode or a temperature or just any number of things. So that's because of over the years that's other people have encroached on my expertise. I've had to kind of let them have certain areas and I go work in other areas in a way. But I've had a nice long career doing that sort of thing, and it's hardware and electronics. I'm not sure how popular that is. Everybody wants to do software and do embedded systems. And so the hardware part of it is something that I think there's still a very definite need for, but I suspect you will be in high demand if you're able to do that type of work. So that's kind of, what I've been doing and where I get the expertise to talk to you about this, and be happy to answer any questions you might have, or I can talk about some other things if you'd like.
So I guess with that, we'll just go ahead and open it up to students. I do believe I heard some that had some industry questions, so I guess I'll open it up to them.
What is it that electronics engineers do like on the job?
So if I hired an electronics engineer, what would they be doing if they worked for me? Is that the gist of that question?
Yeah, basically.
So we're actually, looking for someone now, but we need someone with maybe 5 to 8, 10 years experience, because what we'd be looking for someone who can basically do some of the things that I do, design hardware, design. Some of it is transistor level design. A lot of it is op amps. A lot of it is amplifiers. A lot of it is designing power supplies and regulators. So typically, when we design, let's say I have a battery operated device, I may have to have 3 or 4 different voltages that run, let's say 12 volts to run a pump, 5 volts to run a liquid crystal display, and the microprocessors are all running, and other circuitry are running off 3 volts or 3.3 volts. I've got to take a battery and then convert that over, which may be 3.7 volts if you got a lithium ion, and we just did one where we had to kind of put 2 of them in series so we could properly protect them. So we're trying to run that 7.4 volts and develop all those supply rails off of that. So I need someone who can design switching supplies. So you can see that there's a lot of details that go into it, and we also have to have an understanding of how to design things that prevent electromagnetic interference from either emitting that, or it going out of our circuitry or affecting our circuitry. So we're always designing protections both in and out and off the board. So those are the kinds of things we'd be looking for, someone who has experience with that. What we would love to have as an auxiliary to that is the ability to do embedded microprocessor systems and design using microcontrollers or microprocessors to do, depending on the level of need for the control and functions that might be needed there. Does that help a little, or?
Yeah, thank you so much.
You bet. So are there many of you who are interested in designing hardware and doing that type of work?
So is it a lot of like mainly only designing hardware? Is there any like you have to use software like with your hardware at all, or do you leave that to somebody else?
Software is always part of it. In other words, I don't know of a system I've worked on in 25 years that didn't involve both. So even the little portable battery operated, they all have microcontrollers in them. It's software, if you like, it's firmware on those, is the way my engineers like to call it. So it's all written in C and compiled down. But yeah, all of that's done. There's always software involved. So we're always interfacing into a microcontroller. My guys take care of those. I used to do that. I started my career doing that, doing microprocessor type work and writing the software. But again, the other fellows are so adept at it, and my strong point is the hardware side of it. So I tend to get them to do that, and then I do the hardware part.
Thank you.
So it seems that there's some questions in the chat. I can read them to you, or
Sure.
you can get them. So
let's see if I can find them right quick.
There'd be a little tab that says chat somewhere.
Well, it says reactions. Let's see, where's the chat tab here? Here it is. Okay.
There's one by Brian Pham a little bit up. I hope I said that right.
Yeah, it says, would electronics be a good option to pick if I wanted to work with semiconductor and solid state technology? In order for you to design semiconductors and solid state technology, you have to understand the applications, right? I mean, you can't design a motor controller chip and design that semiconductor IC without having a good understanding of what it's driving, right? So electronics is a big part of that. I guess you could divorce yourself totally from that and only be designing the silicon, if you like, down at the detail level, but some of it does involve knowing how to specify that device to do the end function. So I would say, yes, electronics would help you remarkably in that area. Is there some more down there that, let's see.
Oh, there's another one.
So which that? This one, which one?
It's at the very bottom. It says, do you think the skills developed from electronics can be implemented into VR or AI technology?
So when you say electronics, so we're always, the electronics is such a part of it. So we were approached not long ago by someone who wanted us to help them with some VR technology. I'm trying to remember the name of the goggles that he was the commercial product goggles that he wanted to convert over to a medical use and wanted to do modifications to it. So in a way, it was something that he felt like he had all the AI and the VR part of it done, and he needed the electronics to help him implement some special features that he wanted to add to that. So AI and VR, so what happens to us is this. We're developing, let's say, a system to do, it's monitoring the activity of the uterus during active labor. And the researcher type that got involved with us had some concepts that he was presenting about the muscle activity of the uterus. And we put this, maybe a pattern of 6 or 7 electrodes on the stomach. And we were getting the signals that would come with that. And there were certain aspects and characteristics of those signals that could tell you some very remarkable information about the status of the uterus in terms of whether they were in an active contraction, whether they were getting this stimulating drug, and whether it was overstimulating or not, and different things. And we hired a PhD who had a wealth of knowledge about algorithms. Now, this one wasn't quite so much the AI and sort of that software that learns. This was more algorithms that could parse out information and then do analysis on it to provide, put things into categories and give you information that was critical for the physician to manage that delivery process. So that's close to that. It's not exactly that, but we were providing the signals, so that's where that came from. It was the electronics, but so it is. They're always kind of married together to some degree. What are you going to do? Where are you going to get the information that your VR, maybe not so much that, but at least the AI, it has to make decisions on? You have a helper.
I sure do. This is my nephew.
So we have some more questions, maybe? I have a technician. He's a ex-military, and he's been with us now getting close to 10 years. And he asked me a question. So I was like, how do you know what devices to pick, what configuration to put your circuitry in, and how to do all this? And it's kind of, part of it comes with experience, and part of it, okay, so when I first got out of college, within a year or two, I was already designing all these hardware systems. It was because that's what I wanted to do. I know that there are some folks that I've dealt with who made really excellent grades in electrical engineering, but I couldn't get them to design a circuit with an op-amp in it. I'm not criticizing them, but some people have aptitude for certain things. So if you have an aptitude for electronics and you enjoy hardware, there's certainly opportunities out there for you. I had some people try to discourage me at some point. I'm trying not to tell this story to offend anyone, so don't be offended, but this is what someone said to me. I was working when I was a student, I was working at NASA Johnson Space Center, and I really liked wiring up, building these cabinets of equipment and watching the engineers check it out and learning from them how they were doing it. We put in a weather station, I don't know, oil rig out in the Gulf, and it was transmitting information back to NASA Johnson Space Center, and we got that information, and then we put together the racks of equipment and helped them wire it up and check it out. And so it was a big learning experience. That's what I liked doing. It was hardware. So I was building things. And I had a guy that our group, they wanted to get one of the co-op students out of our group and send it to a group that was over in mission control or something. It was all computer stuff, and it wasn't the kind of hardware I wanted to do. And I kind of pushed back that I'd rather stay where I was. Well, this guy managed to work his way into a thing where we were going to lunch, and I was in the same car sitting in the back seat, and he said something really ugly to me, like, I hear they're teaching monkeys how to wire up things these days. Well, that was about 1972, and so I've been doing that ever since. So what I'm telling you is, believe in yourself, stop you or distract from you. That's the lesson from that. Is I went, huh, that was kind of mean. And I thought, well, this is what I like doing, and I've been doing it ever since.
So I have a question, actually. I guess my question here for you is, as far as, you know, the technology that you have in your office, like what do you use from day to day, and like what kind of things do you do with it? As far as,
well, you know, we have the usual mix of equipment that people have. If I just turn this around a little bit, you'll see some of it. So you can see that we have a sophisticated oscilloscope and usual function generators and power supplies. So it's all the stuff that's been in your electronics lab at school. We have the we will buy equipment as we need it. So in terms of technology, it depends on the project. You know, if we need something, we'll go out and get it. But it's like all my software weenies, you know, and embedded systems guys. So they'll go get, they'll do the research and decide which family of microprocessors they want, and we'll get the development systems in-house that is needed. So when because we work on such a wide range of projects, it's, you know, every one of them's a little different. And now, you know, so we're going to start working on some more laser projects. I'm probably going to have to get some equipment that measures like delivered light energy and light power, that, you know, because of safety and also just testing the lasers, make sure they're doing what you know, what they were designed to do. So it kind of depends in a way. We have the standard equipment and adequate equipment in that regard. We did just buy something. So one of the things we're doing is testing we're trying to develop a technology that uses ultrasound passed through the head to give an estimate of intracranial pressure. And to do that, we've had to build test pictures. And one of the things we needed to do, we have a box that we put an ultrasound probe on each side of it and send the signal through it and then pressurize it and do things. So we'll buy pressure meters and so forth. But one of the difficulties we had is we needed a better simulation. So we tried to fill that box with gel, and the gel had a lot of air in it. So we just bought a vacuum chamber, a big one, like you know, huge, you know, like it's about 2 to 2.5 feet in diameter. And we bought a vacuum pump, and we put that gel inside there, and we've had to develop a process for removing air from the gel so we can run the ultrasound through it. So like I said, it actually goes, so 1 atmosphere is 760 millimeters of mercury, and it goes to minus 730 with the vacuum pump. So it's pretty much vacuum, and it's huge, and it's a plastic thing. And my technician, I go, you need to put that in the back room, and you need to wear goggles. If things go badly, there's going to be some problems. But you know, that vacuum chamber is designed to hold all that, but until we kind of work with it a while and get some confidence in it. But it was remarkably easy to set up and use. We did it in a day and started working. So when you ask what technology, it's what do we need?
That's really informative. Well, thanks for that. That's really cool. Are there any more questions as far as electronics is concerned? I'm not hearing any. I guess I'll give you guys another minute just in case. All right, so if you guys have any more questions, feel free to speak up. But I guess on that note, so we are moving on from electronics. It is after 4, so we're moving on to the signals, communications, and controls topic. actually. And we have our very first speaker.